Let's go ahead and work out this problem. So there are 7 rotten apples in a crate of 25 apples. So there are total 25 apples, 7 of them are rotten. We want to know how many samples of 4 apples can be drawn from that crate. So for A, we're going to use combinations because the ordering doesn't matter. So we know the combinations of n, choose r. That's what we're going to use. So out of the n objects, we're only going to choose r of them. And this is given as n factorial over n minus r factorial times r factorial. So based on this problem, of the 25, we're going to choose any 4 apple. So this will be the combinations of 25, choose 4. And using this formula above, this would be 25 factorial over 25 minus 4 factorial times 4 factorial. So this would be 25 factorial over 25 minus 4, that's 21 factorial times 4 factorial. And then we can simplify this, or you can just put this in your calculator, but let's just show work for the first part. 25 factorial is simply 25 times 24 times 23 all the way up to 1, but I'm only going to list up to 21 factorial, and you'll see why. So the next is 22 factorial. Now let's stop at 21 factorial, and we're dividing this by 21 factorial times 4 factorial. Now the reason I stop at 21 factorial because this and down here we have 21 factorial. We can cancel them, and then it's easier for you to put this in your calculator. So now you should put in your calculator 25 times 24 times 23 times 22 all over 4 factorial, which is 4 times 3 times 2 times 1. And once you put it in your calculator, you'll get about 12,650. So that's how many sample of 4 apples can be drawn from this crate. Now let's take a look at the second part. We want to find how many sample of 4 could be drawn in which all 4 are rotten. So how many are rotten? Well, we know 7 of them. So of those 7, we're going to choose 4 of them because we want all of them to be rotten apples. So for the second part, we will have the combinations. Again, it doesn't matter which 4 we're going to select. Of the 7 rotten, we want all 4 of them to be rotten apples. So this would be given as 7 factorial over 7 minus 4 factorial, 4 factorial. Again, by simplifying, this is 7 factorial over 7 minus 4. That's 3 times 4 factorial. And by doing what we did above, you will get 35. So that's the number of ways to choose 4 rotten apples. Then for the next part, how many samples of 4 could be drawn, which there are 3 good ones and 1 rotten ones. All right, so well, we know that there's 7 that are rotten. So that means of those 25, how many are good? Well, if I do 25 minus 7, I get 18. So there are 18 good ones. So now we can set up our combinations formula. So we're going to choose 3 good ones. So we will have the combinations of 18, choose 3 times. Now how many rotten? We're picking 1 of them, so that's 7. We're going to choose 1. Combinations of 7, choose 1. So this is your choices for good apples, and this is your choices for rotten apples. And we're choosing 3 good, 1 rotten. Now using the formula, this would simply be 18 factorial over 18 minus 3 factorial times 3 factorial times, then we have 7 factorial over 7 minus 1 factorial and 1 factorial. And this would simplify to 18 factorial over 18 minus 3, that's 15 factorial and 3 factorial times 7 factorial over 7 minus 1, that's 6 factorial and 1 factorial. And if you put this in your calculator, you'll get about 5,712. So there are this many ways to do this. Now let's tag in probability to this. So we want to know what will be the probability. So let me clear this up. Let's say if I want to put part D to this problem, we want to know what is the probability of getting all 4 rotten apples. So now that we're thinking this as in terms of probability, we will have to think about it as the number of ways to get rotten apples divided by all possible outcomes. So to answer part D, we can say that the probability that the 4 chosen apples are rotten is going to be the number of ways to get rotten apples. So all 4, right, over all possible outcomes. So now, well, what's the numerator of this fraction? Well, the number of ways we can get all 4 rotten apples, well, that was answered to our part B, that how many sample of 4 could be drawn which all 4 are rotten. So that's actually the combinations of 7 choose 4 over the entire sample space. Well, that's going to be 25, because there's 25 in total. So 25, we're going to choose 4 of them. So the denominator will be all possible outcomes. That's 25 choose 4. And these are the answer to our previous part. So for the first one, that's the answer to part B. It's right here. That's going to be 35. And for the denominator, 25 choose 4, that's this one right here. And that's 12,650. So that's the probability of getting all 4 apples to be rotten. And then if you put this in your calculator, you will get about 0.00277. So very small probability.